So hello and welcome to another episode of Geographics. I'm your interim host, Karl Smallwood. Yes, that's my real name. And today we're talking about Saturn, the crown jewel of the solar system. And this video is based on an original article created by Eric Malekite, who you should give some love to in the comments because they pulled double duty as one of the editors for this channel. A true Renaissance man. Sorry Eric, I'm about to butcher this one that you worked so hard on. While Jupiter may be the king of the planets, there can be no doubt that Saturn is the crown jewel. The haunting beauty of its iconic rings has captivated humankind since ancient times, and the planet still serves as a source of wonder for those who dream of a day when humanity might take to the stars, not in spaceships designed by Elon Musk. These pioneering authors describe luxury trips to tour its rings and complex mining operations to harvest its abundant resources for faster-than-light capable ships. Though humans have yet to develop luxury space cruisers to its rings like in Total Recall, with the advent of NASA's Cassini probe, we've made the dream of exploring Saturn's rings, at the very least, a reality for now. On cold, moonless winter nights, when you're not in a city with lots of light pollution like I am, Jupiter may indeed be the brightest light in the night sky. If you point your telescope at Saturn, you'll be treated to quite the view. With lower power telescopes, you'll be able to experience Saturn pretty much as Galileo and his peers did, clearly identifying its axial tilt of 27 degrees and its trademark rings in stunning, chromatically aberrated, blurry detail. Just like an Xbox game that's not optimised. But perhaps an even more intriguing story is how Saturn itself came to be. The formation of its iconic and surprisingly young rings, as well as its pivotal role in the development of the inner planets. So Saturn as a planet has been known to humanity since ancient times. The Greeks named it Cornus after the titan of agriculture, possibly thanks to its hue being similar to that of wheat. The Hindu nations knew it as Shani, the judge of the planet. Shani was one of the 9 celestial bodies that can influence the lives of mortals here on Earth. To the ancient Hebrew people, Saturn was known as, and I hope I pronounce this correctly, Shabbatai, the planet in charge of the Jewish people. Japanese and Chinese cultures also saw Saturn as the representation of Earth, one of the 5 elements. Despite Saturn's influence on the ancient world, it wasn't until the 1600s when Galileo was pointing his 20-power telescope at the night sky that we would come to learn of its rings. Galileo did not know what these strange ellipsoid shapes were. That particular realization would go to the Christian Huygens in 1655, the astronomer who would go on to discover Saturn's largest moon, the aptly named Titan. Well, anyway, in regards to the moons, the awesomely and Italianly named Giovanni Domenico Cassini would discover Laptus, Rhea, Tethys and Dione in 1671, 1672 and 1684 respectively, while a guy called William Herschel would discover Mimas and Enceladus in 1789. Hyperion would be discovered in 1848 by British scientists, but those are just Saturn's most iconic moons. In total, the gas giant has 53 confirmed moons and 29 that are awaiting confirmation by the scientific community. So they're in disagreement whether or not those are moons or just big hunks of rock that orbit the planet, which apparently doesn't constitute a moon. Who knew? But before we can go any further, we must first talk about Saturn's role in the formation of our solar system itself, because without it, the inner planets might have looked quite differently. And remember, that includes our planet.
Wow. The universe is an incredibly beautiful place, and I don't think people stop enough to appreciate that. Maybe it's because life can be extremely stressful. Especially in today's digital era, ensuring your safety online can provide a whole new level of worry to your life. The sad fact is that there's money to be made selling your data online to robocallers, to scammers, and data brokers are making a fortune out of this. Anytime that you enter your personal data online, there's a chance that it may end up in the hands of these data brokers, and from there, your email addresses, your home address, your phone number, anything could get sold to someone else. The sponsor of today's video, Aura, is fighting back against this. Aura seeks out the data brokers that are holding your information and submits opt-out requests on your behalf, which these data brokers are legally obligated to honour. As you can imagine though, data brokers do not want people to do this, so it's often a very difficult process. Having Aura on your side here will give you peace of mind knowing that it's been taken care of for you. Aura actually does a lot more for you than just this service, as they also offer parental controls, antivirus services, a VPN, password management, and more. Why get a bunch of different apps to cover all of these bases, where you can get one app that does it all? You can either let people continue to exploit and profit off your personal information, or you can go to aura.com/geographics to start your 2-week free trial. We've also provided the link below in the description. Thank you, Aura, for sponsoring this video. I'm going to get back to enjoying the majesty of the universe. Hope you enjoy the rest of the video.
With a radius of about 58,000 kilometers, or for those of you who want exact figures, 58,232 kilometers, Saturn is the second largest planet in the solar system. It's so big, in fact, that storms raging on its surface regularly eclipse the size of the Earth itself. In our Jupiter video, which is probably on screen somewhere, which is presented by my more aerodynamic and erudite predecessor, we talked about how the titular behemoth spent much of its first few million years devouring baby planets like Galactus, called, and this is a real word I'm glad to have learned today, planetesimals, basically planet Lego. And these planetesimals delayed its runaway accretion of gases until a bit later in its development. Saturn began its life much in the same way Jupiter did 4.6 billion years ago. Like Jupiter, it formed at a point thought to be 4 times further out than its current orbit. Also like Jupiter, it began accumulating planetesimals, half-kilometer sized rocky bodies that are thought to be the building blocks of planets. Like I said, Lego for planets. But once the solar system had already been about 2 million years old, unfortunately we can't be exact when it comes to these sort of figures, Jupiter would have begun its grand tack, a 700,000 to 700 million year journey, I told you we couldn't be exact, that would see the king of the planets wreak gravitational havoc on the still forming worlds of the inner solar system. Something, however, kept Jupiter from migrating further into the inner solar system, becoming a hot Jupiter, and that thing is thought to have been Saturn. Like Jupiter, Saturn had also migrated inward during its formation, likely mirroring Jupiter's developmental phases, though on a slightly smaller scale. Slightly in this case being relative, because it's, massive. During that incredible journey, Saturn would not have completed its development, the accumulation of its outer gaseous layers, until Jupiter had already reached a distance of 1.5 astronomical units from the Sun, today known as the orbit of Mars. At this stage, Saturn had accumulated enough mass that its gravitational influence, along with the still forming ice giants, was enough to not only halt the inward progression of Jupiter towards the Sun, but to drag it back into its current orbit of 5.2 astronomical units. So basically, Saturn had our back. Shortly after this, Jupiter and Saturn developed an orbital resonance, which would have cleared any remaining gases left over from the formation of the solar system, but more on resonance later. Soon after this, the solar system would have begun to look much like it does today, with one major exception. Saturn would have not had its iconic ring system. So over the years, we've had many theories about the origins of Saturn's rings. Before Voyager 1 and Voyager 2 visit the gas giant, it was believed that Saturn's rings would have likely evolved as a natural cause of its evolution. But in 1980 and 1981, the Voyager probe rewrote everything we knew about the rings. The data, or data, if you want to be pedantic about it, collected from Voyager 1 and 2 showed astronomers that Saturn's rings are much younger than previously believed, to the point that they're likely to be younger than the planet itself. Fast forward to 1997 with the launch of NASA's Cassini-Huygens double spacecraft, named after the two influential astronomers we've already mentioned, that had made numerous discoveries regarding the planet Saturn. Cassini will spend about 7 years travelling to the outer reaches of our solar system, at which point it will spend another 13 studying Saturn and its rings. While Cassini is notable for revealing much about the earliest period of our solar system, allowing us to see Saturn's weather up close and personal for the first time, and revealing the potential life-bearing nature of several of its moons, he also made a startling discovery about its iconic rings that we've only just begun to understand today. Those rings aren't just young, they're as young as the dinosaurs, and again, this doesn't sound impressive, the dinosaurs are like 60 to 100 million years ago, but remember, we're talking relatively here. The planets are billions of years old. The rings are only a few million. It's somewhat mind-blowing to think about the fact that if you were alive during the time of the dinosaurs, could avoid being eaten by a dinosaur, and just so happened to have a telescope and pointed it at Saturn, you would not see the rings at all. And that is, of course, because they wouldn't have formed yet, which you're obviously asking, but how do we know this? So, in the past, astronomers believe that Saturn and Neptune shared something called gravitational resonance, evidenced by the fact that when observed from Earth, Saturn and Neptune have a nearly identical axial precession, which refers to the direction of a planet's wobble as it relates to the fixed position of stars. Yes, much of astronomy is just looking at big things wobble in the sky. Between the years 2004 and 2017, astronomers hypothesized that Neptune's gravitational pull was the cause of Saturn's tilt. However, instead of finding evidence supporting this hypothesis, they found that Titan was moving away from the planet at a rate of about 11 centimeters per year, which again doesn't sound like a lot, but this is a moon we're talking about. And this was much faster than predictions had suggested. Be sure to check out a video on Titan to learn more. This led many scientists to conclude that Titan's, again, relatively fast migration away from Saturn was more than likely responsible for its axial tilt and its resonance with Neptune. But there was a serious problem with this hypothesis. We need to know what Saturn's moment of inertia was. So again, if anyone doesn't know, in physics we define a body's moment of inertia as the measure of the rotational inertia of a body. I know, it makes perfect sense, right? So a recent paper published by Science in 2022 details a fascinating hypothesis for how Saturn may have developed its rings. In order to figure out that hypothesis and whether or not it was correct, first its authors, which included the aptly named Jack Wisdom, had to find this moment of inertia. Essentially, this entailed figuring out the opposition that Saturn displays while its rotation is altered by the application of turning force. I am back in high school and I don't like it. The thing is, when Wisdom and his team actually found that moment of inertia, it told them something altogether surprising. Saturn and Neptune are not in orbital resonance as previously thought. However, they were in the past. This meant that at some point in the recent past, again, we're speaking relatively here, this is a time frame of millions of years, the two planets somehow fell out of orbital resonance. They had that messy breakup, and then suddenly Saturn had its rings. So the question is, why? And perhaps more importantly, when? So Wisdom and his team ran dozens of simulations attempting to figure out what could have caused this shift, and they arrived at one real conclusion. Somewhere between 100 to 200 million years ago, one of Saturn's moons became destabilized and crashed into the planet, knocking it out of resonance with Neptune. This lost moon, dubbed Chrysalis by Wisdom and his team, would have experienced a decaying and unstable orbit. It would have flown dangerously close to Titan and Iapetus, and on its return journey would have come close enough to Saturn to graze its surface. This grazing blow would have torn the moon apart, with much of the material coming back around to collide with Saturn, but a fraction of it would have fanned across Saturn's equator and become its rings, that countless people on Earth have come to know and enjoy. The thing is though, this story for how Saturn's rings came to be is not all Cassini found evidence for, as the rings themselves provided plenty of surprises for both scientists behind Cassini and those that will come to study the vast stores of data it beamed back to Earth before its final moments, which were awesome and we'll get to in a moment. So if one were to approach Saturn from a rocket and then dive into the planet, the first thing you'd do is die. It's real big. There's 400 mile an hour winds and the gravity is Vegeta would struggle surviving that. Well, the other thing you'd notice is its complex ring system and the inner moons that orbit through and around them. Saturn has as many rings as Star Trek has Enterprises. The closest ringlet in the formation of the gas giant, Saturn's D ring, followed by the C ring, the B ring, and the A ring, which all makes sense, right? But that's followed by the F ring, the G ring, and then the largest, the E ring. And if you're wondering why they go in such an awkward order, it's worth noting that they were named in order of their discovery, and we didn't necessarily discover them in the order they went out or into the planet. Just another one of those things. Maybe scientists should rename it, because that is really awkward. At least give them a cool name, like Titan, Prometheus, Pandora. Those are all things. Those are all words that stick in your mind. Anyway. So some of these rings were not discovered until well into the 20th century. So it's probably an understatement to call the ring system huge. The rings start at an average of 282,000 kilometers above Saturn's surface. The E-ring, for example, stretches all the way from Mimas's orbit to Titan's, a distance equaling almost 1 million kilometers from the surface. While that's certainly impressive, it's equally surprising, at least to me and the author of this piece, Eric, the rings are only about 9 to 10 meters tall. So for comparison, the houses most people live in are only about 5 to 6 meters tall. So they're millions of kilometers across and only 10 meters tall. That is surprising. Very thin. Beyond the B ring is a gap known as the Cassini division. It separates the A and B rings from one another, and it's the largest division between any of the rings that we know of. Saturn's A ring, on the other hand, is probably the one people like myself and the viewers at home, just casual observers and enjoyers of space. That's the one we'd likely be familiar with, because it's the one that's most easily observable from the surface of the Earth. Following that is the F ring, which is shepherded by Prometheus and Pandora, some of Saturn's smaller moons. Moving on to Saturn's G and E rings, these are even fainter than the D ring. The E ring is the final and largest ring, and it's composed primarily of carbon dioxide and ammonia, as well as silica particles and super small grains of ice. That's ice, not rice. When I first read this, when I was doing the my run through before we record, I was wow, grains of rice, and then I realised I'm an idiot. It's obviously ice. Karl, you idiot. So before Jack Wisdom's lost moon hypothesis, scientists believed that the rings were composed of asteroid and cometary fragments that were torn to pieces by Saturn's immense gravitational field. Though that hypothesis likely does not hold water anymore, the rings are indeed mostly made up of chunks of dust-covered ice and rock. An interesting note that gives Jack Wisdom's hypothesis even more plausibility is that all of Saturn's large moons that orbit within the E-ring are made up of varying degrees of water ice. And if you're wondering, why do we have to say water ice instead of just ice? Because isn't all ice water? Well, that's probably true on Earth, but not so much in the solar system where temperatures can reach close to absolute zero. For example, you have the frozen methane on Titan and Pluto, carbon dioxide on Mars, and that's not to mention the 19 other states of ice that water molecules can assume, with the right combination of pressures and temperatures. And yes, they're all ice as well. So these dusty chunks of ice and rock can range from mere microns to chunks the size of a house. But these rings will not last forever, and eventually Saturn will get its Beyonce on and become a single lady. Because according to new research based on rates established by Voyager 1 and 2, Saturn's immense gravity is slowly pulling the iconic rings into its upper layers. Estimates suggest that within 300 million years, Saturn will once again be single and without its rings. So as the sixth planet from the Sun, Saturn orbits at an incredible distance of 1.4 billion kilometers. Contrasting that, its days are relatively short, clocking in around 10.7 hours. It takes a whopping 29 Earth years for it to complete one trek around the Sun. So as a reminder, if anyone just try to remember from high school, a day is one full rotation, a year is a rotation around the Sun. And I've always wondered this, how would birthdays work on one of these planets? Say, we make it to Mars. You're living in Elon Musk's Mars slave colony. What do your birthdays look like? Do you celebrate like you would on Earth, or do you celebrate Mars birthdays? These are all questions that I know probably astronomers are sick of getting asked on Twitter. So I'll ask you, our comment section, to let me know. Saturn is also one of the few planets in our solar system to experience seasons. Not as we'd know them, but seasons nonetheless. So during Saturn's winter, great shadows are cast upon its winter hemisphere. This is a consequence of Saturn's rather large axial tilt and its vast system of rings casting deep shadows across the surface. If you were to observe the Sun from our hypothetical rocket from this region, it would be especially dim. Saturn is primarily made up of hydrogen and helium, much like Jupiter and the Sun. And the author of this piece has helpfully provided just a couple of bits of trivia about Saturn to break up the vast information dumps, which I'm thankful for. So, lightning round now. Saturn is primarily made up of hydrogen and helium, much like the Jupiter and the Sun. And secondly, despite Saturn's popularity, it's only been visited by 3 spacecraft so far. So, back to the information dump. So the first 2 spacecraft to visit Saturn were the Voyager probes, Voyager 1, Voyager 2. Very, very creatively named there. During its 1980 flyby, Voyager 1 added Atlas, Prometheus and Pandora to the planet's growing pantheon of moons and discovered the latter 2 were responsible for shepherding moons that occupy the E-rings. Effectively, this means that Prometheus is actively carving out a division between the 2 rings. The probe also discovered the planet's G-ring, a word I'm not going to be able to stop trying to stifle a laugh while saying. Titan had a thick nitrogen atmosphere, and data beamed back to Earth suggests that Saturn's atmosphere was about 7% helium and 93% hydrogen. The exact ratio is still something of a mystery even today. Voyager 2, on the other hand, will perform its own flyby in 1981, discovering geysers on Enceladus, Earth-like qualities on Titan, and evidence that Saturn's rings were an actively changing environment. While all of these discoveries were quite impressive for their time, in January of 2005, Cassini, the 3rd spacecraft to visit Saturn, began an impressive observation run that concluded in 2017, with the spacecraft taking a dramatic, sacrificial dive into the planet's atmosphere. I told you, it was rad. Over the course of that decade-long mission, Cassini made countless discoveries relating to Saturn's moons, including launching the Huygens probe and sending it into Titan's atmosphere, shocking the scientific world with the first view of an alien oily ocean. Like Jupiter, Saturn's surface is ravaged by layers of clouds called cloud decks, all of which are contained within the planet's atmosphere. Each of these layers are dominated by complex storms and winds that can reach 1800 kilometers per hour at the equator, making Saturn one of the windiest planets in the solar system. If we were to take our hypothetical rocket deep into Saturn's clouds, we will see that these cloud decks are divided into 3 layers. Vicious white storms periodically tear their way to the surface. While not as iconic as Jupiter's Great Red Spot, each one of these could easily swallow the Earth whole. At the stratosphere, the temperature is a steady minus 133 to 123 degrees Celsius, with pressures around 1 millibar. The topmost cloud deck is composed mostly of ammonia clouds and is found about 100 kilometers beneath the uppermost region of Saturn's troposphere, which extends deep into the planet's cloud systems. Temperatures in this region are impossibly cold, coming out at minus 250 degrees Celsius. It is here that pressure begins to increase, ranging from 1 to 60 millibars from the top to the bottom of the cloud deck. Diving deeper into the gas giant, reaching 170 kilometers beneath the troposphere, the middle cloud deck is dominated by ammonium hydrosulfide clouds. Here the temperature increases to a, admittedly, much more palatable, minus 70 degrees Celsius, and the pressure increases to 1 bar. While the cloud visible from space appears almost colourless, in these regions they display various hues of red, yellow, and even brown. These vibrant colours are the product of chemical impurities. If we dove even deeper to the lowest cloud depth, the temperature evens out to a freezing 0 degrees Celsius. It's here that the hydrogen gas that makes up the majority of Saturn's composition begins to transform into a liquid thanks to an increase 4.7 to 10.9 bars of pressure at the bottommost region of the cloud deck. And just imagine that much pressure that it can turn air into a liquid. It boggles the mind. It's fascinating, and I don't understand how it works, but it's still amazing to learn. Beneath this layer of liquid hydrogen stretches a layer of liquid helium, and still even deeper into this, the planet's pressure becomes so great that its hydrogen is transformed into metallic hydrogen, much like Jupiter, but not nearly as large. Like, imagine that. It crushes air into metal. That's so metal! That's so cool! This conductive metastable ocean contributes to the planet's powerful magnetic field. A magnetic field that, for those curious, is about 578 times stronger than the one here on Earth. So it's just like, you stand on that planet's surface, if you even could, and just like Magneto's got you. Terrifying. Beneath the deepest reaches of that ocean, however, lies Saturn's rocky core. Saturn's core is composed primarily of iron and nickel, as well as various other compounds. The intense pressure and heat forces these materials to remain completely solid. Beyond Saturn's basic structure, its composition, its rings, lies a series of mysteries that scientists are eager to know the answers to, such as the planet's mysterious hexagonal polar storm. And it should be called Saturn's Mysterious Hexagonal Storm, because what the hell is that? So originally discovered thanks to observations made by Voyager 1 and 2, Saturn's mysterious hexagonal storm that occupies its north pole is as eerie as it is awe-inspiring. The geometric storm system spans some 30,000 kilometers across and is dominated by 322 km/h winds. Perhaps the strangest thing about this storm is that it seems to be the only one of its kind. All other storms that form similar geometric patterns do not seem to have the staying power of Saturn's hexagon, which is band name calling it. The storm has lasted for decades, and while scientists believe that one contributing factor to the storm system's longevity is Saturn's lack of a natural solid surface, no definitive answer has been found. Cassini was able to observe the hexagon for about 10 hours, allowing us an incredible view of the storm in unprecedented detail. Just again, Saturn's hexagon, band name calling it. Over the years, many hypotheses have been offered up offering to explain the storm's strange properties, such as Oxford University's proposal that these storms are actually caused by a deep latitudinal gradient in the speed of Saturn's atmospheric winds. That was a sentence. This hypothesis was accompanied by a laboratory experiment that aimed to replicate the storm's unique pattern, with a rotating circular tank filled with liquid and various dyes. The experiment was able to successfully demonstrate a hexagonal formation similar to that of Saturn's polar vortex, though it also produced shapes with 3 and sometimes even 8 sides. In 2020, a scientific paper made the claim that the hexagon storm was most likely caused by deep atmospheric flows within the planet that create cyclones of varying sizes around the horizontal jet stream. Saturn's lightning is another mystery captured by Cassini. In these stunning photographs of the planet, we can see bright blue spots discharging from within a raging storm that engulfed much of the planet in 2011. These lightning bolts were observed to have diameters as massive as 160 to 200 kilometers across. 200 kilometer bolts of lightning in a storm the size of the Earth. If that's not where Doctor Doom lives, I don't know what we're doing. So it's unknown why these flashes showed up in Cassini's blue image filter, or what colour they actually are. Oh man, red lightning, let's go. Like Dark Raiden from Mortal Kombat, I'm ready. But perhaps the biggest mystery of all came when Cassini began its final grand descent into the planet's cloud layer. So during this final maneuver, let me rephrase that. During this final heroic maneuver, Cassini traversed the planet's iconic ring system and encountered far less dust than scientists had originally anticipated. But that could not possibly compare to Cassini's historic sampling of Saturn's atmosphere. 2 days before that iconic final plunge, Cassini took one last shot of Enceladus on Saturn's horizon. Titan, the small ring-dwelling moon, Daphnis, its rings, and finally the planet itself, before making the ultimate metal sacrifice for science. The Voyager probes had previously observed a phenomenon known as ring rain, which occurred as a result of material from Saturn's ring systems interacting with the planet's atmosphere, which caused direct changes to it. The samples and observations by Cassini during this final run hinted at a complex relationship between particles in the ring system and the upper atmosphere. Saturn has a habit of surprising those who study it, and this discovery was certainly no exception. So mission scientists would have liked to have more time to collect observations and data from Saturn's rings, but sadly, with Cassini's fuel supply running low, there was no stopping its sacrificial dive into the planet's atmosphere. Yeah, they crashed the satellite for science. This final dive was a chance to make one last journey that would hopefully help future scientists better understand the planet's complex composition and solid core. And considering that most of the data used to write the script for this video was taken from Cassini, we'd say it did just that. So you know what? Well done, Cassini. And just, I'm going to, this is obviously a very meticulously researched and written article with lots of, scientific jargon. It's very well written. I'm just going to put it into, more broad layman's terms. This satellite crashed into a planet that is basically just one giant storm with lightning bolts the size of states while just taking pictures. It's like, it is that scene from Doctor Strangelove, the guy riding the bomb times infinity. That is so metal. So, finally, on September 15th, 2017, at 11:55:46 UTC, Cassini's signal was lost and was followed shortly by the spacecraft's destruction. Saturn is a beautiful and fascinating planet that has a wonderful habit of surprising everyone who gazes up as its ring-encased form. As much attention as Jupiter has gotten by the world's space agencies, it's a wonder why more probes have not been sent to Saturn. But thankfully, in 2027, NASA will be launching Dragonfly. In 2034, Dragonfly will explore Saturn's largest moon, Titan, and is designed to fly through its atmosphere like a drone, sampling and exploring its strange and alien surface. But as great as that sounds, there appears to be no plans for NASA to revisit Saturn's surface or its rings anytime soon. Here's hoping that some other space agency decides it's worth the time, effort and money to return to the crown jewel of the solar system once again. Every time we return to Saturn, it's sure to surprise, shock and keep us in awe of the scientific mystery still hidden from our comprehension. So thank you for tuning into this episode of Geographics. As mentioned at the start, this video was based on an original article submitted by our editor who was pulling double duty. You can find links to his socials and mine, Karl Smallwood. It is my real name. They'll be below. Also below will be links to my own channels, Facting with Karl Smallwood and Wiki Weekends, which are altogether more casual in style than this one, but still, contain a lot of facts and fun, I'd hope anyway. And yeah, if you like the video, leave a like. If you've got any comments, leave them below. In particular, I would like some feedback on my presentation and hosting style. I feel like I'm coming into my own presenting and hosting these videos, but feedback is always appreciated. And finally, subscribe to watch more stuff like this. And as always, have the day you all deserve. Cheers.